Hello everyone, welcome to today's class. This is Teacher Simon taking you through Cambridge International AS and A-Level Mathematics paper 4.3 for May-June 2024. And this is part 1 for questions 1 to 4. Question 1, two particles P and Q of mass 0.2 kilograms and 0.5 kilograms respectively are at rest on a smooth horizontal plane. So there is no frictional force, okay, because it is smooth. Then particle P is projected with a speed of 6 meters per second directly towards Q. After P and Q collide, P moves with a speed of 1 meter per second. Find the two possible speeds of Q after collision. Now, since P is lighter than Q, okay, it can collide with Q and continues forward, or it can rebound. It can collide with Q and continue to move forward or rebounds. So those are the two scenarios we are going to look at. Now let us look at when P moves forward. Okay, when P moves forward. So what happens? Now I have my particles here, and then after collision, so this P here is 0.2 kilograms. Q is 0.5 kilograms. 0.2 kilograms, that is P, then Q, 0.5 kilograms. Now, U is projected towards Q at 6 meters per second. Okay, and of course the U of Q is going to be 0 because it is at rest. Okay, then after collision, velocity of P, now P is moving forward. It is 1 meter per second, and then that of Q, we don't know it. Okay, now they have said that find two possible speeds of Q after collision. Now, applying the principle of conservation of momentum, momentum before collision is equal to momentum after collision. Okay, so we shall have MP UP plus MQ UQ, because you know that momentum is product of mass and velocity. Then MP VP plus MQ VQ. Now we have here 6 times the 0.2, okay, then plus for Q the momentum is going to be 0, and then after collision we have the mass of P, which is 0.2, then times its velocity, which is 1 now, and then the one of Q, the mass is 0.5, then VQ. So finding VQ will then be 6 times 0.2, that is 1.2. Then we shall subtract this 0.2 from here. Then we get a 1. Then 1 divided by the 0.5, V of Q is going to be equal to 2 meters per second. Then also, let's look at when P rebounds. Okay, when P rebounds, we are now going to look at it now facing this side. So substituting here, we are going to have 6 times the 0.2, then plus, of course, the momentum of Q is 0, because it is at rest, and then the mass of P is 0.2 times the final velocity is -1, because it is rebounding, okay? Then plus mass of Q is 0.5, then V of Q, so meaning we shall have 1.2, then plus, when this one comes this side, it is a plus, so we shall have 0.2, and then divide by 0.5. That will give us the VQ. So meaning our VQ, 1.2 plus 0.2, that is 1.4, then divide by a half, then VQ becomes 2.8 meters per second. As simple as that. Question 2. A particle of mass 0.2 kilograms is attached to one end of a light inextensible string. The other end of the string is attached to a fixed point on a vertical wall. They are saying that the particle is held in equilibrium, okay, by a force of magnitude x newtons perpendicular to the ring, 90 degrees here, with the string taut and making an angle of 30 degrees with the wall. Okay, now when we are supposed to put the forces, okay, that are acting on this particle. So this being a string, for it to be this taut, it must be having a tension within it, okay? And this particle here has mass which acts directly downwards, the weight, which is 0.2 g, okay? And then if I may put a horizontal here and also this other side like that, this is 90. So if this is 30, then that means that the angle which is here is 60 degrees, okay? And then if this one here is 60 degrees, then plus 90, that will be 150. That means this one has to be 30 degrees. Why am I finding these angles? It's because I want to resolve the forces, and I must be knowing the angles that I'm going to use, okay? Now close this one here. When I close it, it is going to give me a cosine. So we shall have x cos of 30. Now we are going to also resolve here, okay? We're also going to resolve here. Now, since when we close in, it is cosine, then opening has to be a sine. So here we shall have x sine of 30. Then we also come to this t. I can just consider this one coming down here. Then it can be t cosine of 60 degrees. Okay, cosine of 60. And then open it here. Then I can have t sine of 60 degrees. Okay, now they are saying that the system is in equilibrium. So if the system is in equilibrium, that means we don't have a resultant force vertically and also horizontally. So resolving the forces horizontally, if you look at the ones horizontally, we have these ones here. Okay, so we shall have t cos 60. Then this one is equal to the x cos 30. X cos 30. And then cos of 60 is a half. So we shall have a half of t, then is equal to cos of 30 is root 3 over 2. That means if I multiply all through by 2, then t is equal to root 3 of x. Okay, I can keep that. Then next I can go vertical. So resolving forces vertically, what do we see? Up there we have these ones here, t sine 60 and x sine 30. T sine 60 plus x sine 30. Then this one is going to be equal to, the one going down is the weight, 0.2 g. And then since we have our t as root of 3 of x, then times the sine of 60 is root 3 over 2. Then plus sine of 30 is a half, so of x, then is equal to this way 2. Because when we multiply through by when we multiply by 10, g is 10. Then after this, I can factorize, x is common. So here I have root 3 times root 3. That is the same as 3 because it is like root 3 squared. And the square cancels the root. Okay. So here we are going to get 3 then over 2. So 3 over 2 then plus 1 over 2 here. 1 over 2 then is equal to 2. Of course, this one will be 4 over 2, which will be 2x, which is equal to 2, and then dividing through. That means x is equal to 1 Newton. Now we can substitute back into t. That means our t is going to be equal to root of 3 newtons. So those are our answers there. Question 3. A car travels along a straight road with constant acceleration a meters per second squared, where a is greater than 0. The car passes through points A, B, and C in that order. The speed of the car at A is u meters per second in the direction AB, and the distance BC is twice the distance AB. The car takes 8 seconds to travel from A to B and 10 seconds to travel from B to C. Then they want us to find u in terms of A. Now, let me do something here. Let us do a simple sketch here. So let's say I have point A here, and then I have point B here. Then I have point C here. Then they have said that the distance BC is twice that of AB. So if this is x centimeters from here to here, that means this one is going to be 2x. Okay? 2x there. Then this one, it takes 8 seconds to move from A to B, and it takes 10 seconds. 8 seconds from A to B, and then 10 seconds from B to C. Okay, then when it passes point A, it is moving at a speed of u. You see? Now, let us look at the movement within A and B. So if we say S is equal to ut plus a half at squared, here we are using these equations of motion because acceleration is constant. Okay, they said constant acceleration. Then the distance is x, which is equal to u, and then the time taken is 8. So 8u then plus a half times the a, which we don't know, times the t, which is 8 squared. So 64 divided by 2, that is 32. So we can have 8u plus 32 of a. That is my first equation. Okay. Then let's look at the movement from A to C. Okay, A to C. I'm not using the movement from B to C because I don't know the speed here also. You see that? So I can just take from here and here such that u is common. Okay, so from A to C, I can have, I'm substituting also here, s is equal to ut plus a half at squared. So the distance is x here plus the 2x, which gives us 3x, which is equal to u, because we are starting from A. And then the time taken is 8 plus the 10. So that means we shall have 18 here. Okay, 18, then u plus a half a, t is 18 squared. Okay, now here we shall have our x. Remember, x is 8u plus 32 of a. So I will just substitute. Okay, then this one is equal to 18u, then plus, this is a half of a. Okay, let us simplify this right away. 18 squared is 324. 324 divided by 2, you get 162 of a. Okay, now when I multiply all through, this one will be 24. When I open the brackets, 24, then plus this is 96 of a, and then this one will be equal to 18u plus 162a. Remember, they said find u in terms of a, so we make u the subject. Okay, now automatically we shall have, there is u here, okay? Now 24u minus 18u then shall be equal to 162a minus 96 of a. So 24 minus 18, that one gives us a 6. So 6u then is equal to, this one will give us a 66. Okay, so when we divide all through by 6, then our u becomes 11 of a, like that. Then part B, find the speed of the car at C in terms of A. Speed of the car at C in terms of A. So we can use SC, okay? SC. We have V, which is equal to U plus AT. So we want this speed of the car at A, the final velocity. So the U, we have gotten it as 11 of A. So we shall put 11A, then plus A here, times the time taken is the 8 plus the 10, which is 18. So we have 18 of A. That means V here is going to be equal to 11 plus 18, you get 29. So it will be 29 of A, just like that. Question 4. A particle travels in a straight line. The velocity of the particle at t seconds after leaving a point O is v meters per second, where v is equal to k t squared minus 4t plus 3. The distance traveled by the particle in the first 2 seconds of motion is 6 meters. You may assume that v is greater than 0 in the first 2 seconds of its motion. Find the value of k. Okay, so since they have given us the distance, okay, then we need to find the expression for the displacement. Now, also, since they have given us an expression for the velocity, then we should know that this is under variable acceleration. So therefore, we don't use the other 3 equations of motion. V is equal to u plus at, s is equal to ut plus a half at squared, and then the v squared is equal to u squared plus 2as. We don't use them, but instead here we use differentiation and integration. So if velocity is the rate of change of displacement, ds dt, this simply implies that displacement is the integral of velocity with respect to t. So we integrate k t squared minus 4t plus 3 with respect to t. Remember, when you integrate, you increase the power by 1. So this becomes a 3. You divide by that new power. Then 4t squared here over 2. Then 3t, okay, here, and then plus a c. So we are putting that c there because we don't know the value of the constant which went when they differentiated. However, at t is equal to 0, okay, they say the velocity of the particle at t seconds after leaving point O. So after leaving point O, that means at O, the t is 0, even the displacement is 0 at that point because it hasn't moved any further, okay? So that means s is equal to 0. So in that case, c is going to be equal to 0. So the expression for the displacement is going to be kt cubed over 3, then minus 2t squared, then plus 3t. At t is equal to 2. T is equal to 2. The displacement is 6. So we substitute. S is equal to 6. So we shall put 6 here, which is equal to k, then 2 cubed over 3, minus 2, then 2 here squared, plus 3 times 2. So now what is left is to find the value of k. So 2 cubed is 8. So we can have 8 over 3 of k. Then minus 2 squared is 4 times 2. That is negative 8. Then this one is 6. Automatically here we are going to get negative 2. When it crosses and it adds to a 6, we get 8. Then 8 over 3 of k. So if I want to get k, I can cross multiply. Okay. We shall have k equal to 8 times 3. Then after we divide by 8, automatically 8 will go. And then our k becomes a 3. Then part B, find the value of the maximum velocity of the particle, you do not need to show that this velocity is minimum. Now, for minimum, just like in pure math, if you are finding the minimum or maximum point, you differentiate and equate to 0, right? So for minimum velocity, okay, dv dt has to be equal to 0. Remember, our v is equal to kt cubed, kt squared, so we shall have 3t squared minus 4t plus 3. So what is dv dt? This one will be equal to, drop the power and reduce it by 1. So 2 finds a 3, it becomes 6t, then minus 4, then equal to 0. That means our t is going to be equal to 4 over 6, simplified to 2 over 3. So then what is the value of the velocity when t is equal to 2 over 3? So you put 3, then 2 over 3 squared, and then minus 4 into 2 over 3, okay, then plus, pardon me here, then plus 3. So putting all of this in the calculator, what do we get? 3 into 2 over 3, then squared minus 4 into 2 over 3, then plus 3. So it gives us 5 over 3. It is a recurring decimal. I can write 1.67 to 3 significant figures, or I can actually leave it as 5 over 3 meters per second. Just like that. So this has been it for this first part of this paper. Thank you so much for watching. May God bless you. If you find the content very helpful to you, kindly like, share, and even subscribe. See you in the next videos.